Hello guys, welcome back to the university, and if you are new to our channel, please click the subscribe button and hit the notification bell to get updated whenever we post new videos or new lectures about physics, about mathematics, about chemistry, biology, and earth science, and probably about school subjects, about the subject matter that you encountered in school. It will ensure that you will have good grades from now until the future. Alright, so let's dive into it and explore the concept of free fall motion. I hope you are familiar with high structure like this, wherein some daredevils or statmen are trying to jump from the top of the building or top of this structure, and once they jump, they are under the influence of gravity, and hence they are in a state called as free fall motion. So once they jump, there are variation in their weights. The question is, which one will fall first? Lighter objects, like this, face mask, or heavier objects when dropped at the same height? I hope you are able to see the results. Alright, so does air resistance matter? If there are variations in the result, you will reason out because the face mask is lighter or the feather is lighter and there is strong wind and so on and so forth. So we are going to explain all of that here in the university. Alright, so and you will notice that there is a difference in their speed. Alright, so is it constant? If it is constant, what is the constant value? We are also gonna determine that. And since this is about physics, you will expect a little bit of mathematics. And we are going to determine the equation or formulate the equation that will describe the free fall motion accurately in a mathematical manner. Answers to these questions are determined experimentally. Alright, so one famous experiment was conducted on the moon during the Apollo 15 mission by the astronaut in the person of David Scott in the year 1971. He had performed the hammer and feather experiment on the moon. So if you are on the moon and if you're gonna drop a feather or a hammer and the hammer simultaneously, the question is which of the two will hit the surface of the moon first. So if you want to know the result of the experiment, I'm gonna leave the link below, which is this one, http://www.archive.org/details NIX 15 1998 blah blah. Alright, so you just have to visit that and you will know the result of the experiment. Alright, moving on. We define air resistance as the force of friction. So when we say friction, it tends to oppose or to slow down the fall of a certain body. So air resistance matter because it counteracts the force of the acceleration due to gravity. So there is a big factor. So air resistance is a big factor. On the surface of the earth, if we are going to drop a hammer and a feather on the same height, the hammer will fall first because it is not so much affected by air resistance. On the contrary, our feather will fall later or slower compared to the hammer because it is largely affected by air resistance. So air resistance is a big factor. So we try to answer the next question, which is which object will fall first, lighter object or heavier object? This experiment was, or the answer to this question was determined by Galileo Galilei in 1564 to 1642 in the Leaning Tower of Pisa. Okay, so on the top of this particular Leaning Tower, he conducted the cannonball dropping experiment wherein he dropped several types of cannonballs, small cannonballs or lighter cannonballs and heavier cannonballs. Alright, so both of them are spherical in shape, so the effect of air resistance is minimized. So he has found out that there is just a little discrepancy on the results. He must have concluded that there is a particular constant value of acceleration due to gravity. And how can we determine the value of this constant acceleration? Alright, so during those days, we do not have the complicated clocks or watches to get the time. So what Galileo did is vary the experiment and create a certain time measuring tool of interval, and he used the fluid. Alright, so as a clock. And to control the ball or the motion of the ball in one path, and to determine the length of the path, he used a certain inclined plane. So he tried to get the distance traveled by this particular ball along the ramp with respect to the flow of the fluid. So that is how ingenious he is, because we do not have accurate clocks during those times or stopwatches during those times. He had devised another way on determining the rate of distance traveled by the ball to the rate of flow of the particular fluid. So Galileo played on his setup. Okay, so he tried to vary the height or the starting point of the ball and measure the distance. Okay, so that is traveled with respect to his ingenious clock, which is the flow of water. And he has found out that after repeating such experiments, he always found that the spaces traversed by the ball is always equivalent to the square of the times, and yeah, it is all true for all the experiment. Meaning to say, it is proportional to the length of the time traveled, time squared, and a certain constant. And we are going to determine that particular constant in the next mathematical analysis. So if we are going to repeat the experiment today, having the complicated clock and timing apparatus or measuring apparatus, we can gather this data. Alright, we have the distance and we have the time traveled, and we can graph it. Alright, so we are going to pay attention to the table here. Distance 0 meter at time equals 0, then 5, 20, 45, 80, 125, and 180 respectively. And once we graph it, we show that the graph of this is a parabola, and it concludes that we are indeed dealing with a quadratic equation. Okay, so using the data and a little bit of mathematic tricks, okay, so we can see that this is the time covered or that has passed by, and this is the distance covered, and the distance covered seems to follow a certain pattern, and in mathematics this is called a quadratic sequence. And a quadratic sequence has a first difference and second difference. Okay, so we're gonna get the first difference, that is 20 meters minus 5 meters, and that's gonna be 15. And we're gonna do it with 45 and 20. We're gonna do it with 80 and 45, and 125 and 80. So those are the first difference: 5 meters, 15 meters per second, 20 meters per second, 35, and then 45. And then we're gonna get the second difference, that is 15 minus 5, 25 minus 15, which is 10, 35 minus 25, which is 10, and 45 minus 35, which is 10. Okay, you will see that the second difference is constant, and that is around 10 meters per second in this graph, or yeah, so in this analysis. But actually 10 meters per second is the value of acceleration due to gravity, or yeah, so only the unit is wrong. So here we have found out that there is a particular constant which is equivalent to, or nearly equivalent to, 10 meters per second. So we're gonna do a little bit of mathematical analysis again to formulate the exact equation using the quadratic equation. So according to Galileo Galilei, so he have found out that the distance traveled is proportional to a certain constant and to the square of the time. Okay, so that is equivalent to distance traveled times, or equal to, second difference, because we found out that that is the constant. Alright, so according to our data table, and using the quadratic sequence analysis, that is the constant, and that is multiplied to the time. So from this observation, we are going to formulate our equation. Okay, so we can write it as d, or distance traveled, for d is equal to k, which is the second difference, times t. K is a constant, I just call it a constant like that. And plugging the observation by Galileo, so it is equivalent to this one, t squared, or the square of the time. So the question is, what is the combination that will lead it to be equal to 5? So I can do it by introducing a constant called as 1/2, and then 10, and then t squared. So if we are going to substitute it for a value of 1, so that is 5 is equal to 1/2 of 10, which is 5, and then 1 squared, so that is 5 is equal to 5. So our formula is now equivalent to d is equal to 1/2 k squared. Alright, has a value of 10, or that is our value of acceleration due to gravity. So we can write it as d is equal to 1/2 gt squared. So that is how we formulate the equation for the free fall motion. So to wrap things up, okay, so the value of g is equivalent to the second difference, which is it has a constant value of negative 9.8 meter per second squared. So why negative? The negative sign there indicates that it is directed towards the center of the earth. And you can also use the formula pi squared. Alright, so if you square the value of pi, it will have the value of 9.8. 9.8. Alright, so square pi and you will get your formula. Okay, so generalization, air resistance plays an important role in Earth. Alright, so but in places wherein there is no air resistance, doesn't matter. Okay, so weight of the object does not matter. Okay, because it's not included in the formula. So whether heavier or how heavy the object is or lighter the object is, it will fall. It will reach the bottom of the ground at the same time. Alright, just like doing that. And yeah, so in the absence of air resistance, lighter object and heavier object will fall simultaneously. Alright, so I hope you guys were able to understand this lesson. Okay, before we move on to the complex part, which is heavily problem solving. I hope you guys were able to understand the basic concepts of free fall motion, because that is very important in physics. Alright, so If you want more videos about physics, about this, and you like my explanation, please click the subscribe button and hit the notification bell to get updated whenever I post new videos or lectures here in the university. Bye bye guys, see you soon, see you next time.